Hi, you guys. This is Mrs. Bolin with your 7.3 notes and also the answers to the odd problems. Okay, so here is your warm-up. This question number 1 is, what is the first property of a parallelogram? And it is in the name, parallelogram. And we know that both pairs of opposite sides are parallel. Okay, question 2. We know that if we have angles, if they're opposite angles, they're going to be equal. If they're consecutive angles, meaning they share a side, they're going to be supplementary and add to 180. So looking from this angle to that angle, it is a side, so we have to add them up and make 180. And remember back like a few chapters ago, these are same side interior, which we also knew then were supplementary. Okie dokie. Question number 3. We have opposite sides, and we know that opposite sides are both parallel and congruent to each other. When we're dealing with the measures, we know that we want to use the property about them being congruent. So we would write 4x minus 2 is equal to 6. And then we would add 2 on both sides. So 4x is equal to 8. Divide by the 4. So x equals 2. And then for this last one, it's a little bit trickier because it's not written on the picture. We have to figure out what in the world it's talking about. So it says SW is 17. So from S to W. And then it also tells us from W to Q. So W to Q. Well, remember, our diagonals bisect each other. So they're chopped in half. So I know that those two pieces are exactly equal to each other. So I'm going to write 9x minus 1 is equal to 17. I'm going to minus the 1 on both sides. So I get 9x, just kidding, add the 1. And so we get 9x equals 18. I cannot talk and write at the same time. I'm trying my best here, folks. But okay, so divide by 9 on both sides. So we get x is equal to 2. All right. So that was our warm-up. Today we're going to learn about some special parallelograms. So all of the same properties are true for regular parallelograms. Opposite sides, both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent to each other. Opposite angles are congruent to each other. And consecutive angles are supplementary. And also diagonals bisect each other. But we're also going to add on to those properties for rhombuses, rectangles, and squares. Okay, so a rhombus is basically a parallelogram where all the sides are the same. Okay, so all of the sides are congruent. And so we also know that the diagonals not only bisect each other, but they do it at a right angle. So diagonals are perpendicular bisectors. Okay. A rectangle, this one had all the sides are congruent. Rectangle has all of the angles are congruent. And if they have to add up to 360 and they're all the same, divide by 4, you get 90 degrees. So all the angles are congruent and they all happen to be 90 degrees. Okay, and instead of the diagonals being perpendicular, the diagonals are actually congruent to each other this time. So then the properties of squares would be if you combine all of that together. Okay, so a square is both a rhombus and a rectangle. So on squares, all the sides are congruent. All the angles are congruent to each other, meaning that they're all 90 degrees. The diagonals are not only bisectors, they're perpendicular bisectors, and they are also congruent to each other. So the diagonals are perpendicular bisectors, and they're congruent to each other. So rhombus, all the sides are the same. Rectangles, all the angles are the same. Squares, sides and angles are the same. So if you had like a Venn diagram, the square would be right in the middle there. Okay, so the steps for the problems, you guys are going to be plotting some points again today. We're going to be looking at slopes. If they're perpendicular to each other, which remember perpendicular slopes or lines that are perpendicular, the slopes are opposite reciprocals. So remember, for example, if you had 2, you could put it over 1. The opposite reciprocal of that would be negative 1 over 2. So that's if they're perpendicular. If they're not perpendicular, then we know that they would be a rhombus if all the sides were the same. Okay, then we're going to find the side lengths. If they're all congruent, it's a square. If they are not congruent, it's a rectangle. If you don't remember distance formula or haven't learned it, or if it's not exactly perfect on there, like 90 degrees, and you can't just count, we could also look at the slopes of the diagonals. Remember, a rhombus has perpendicular diagonals. A rectangle does not, but a square would have perpendicular sides and perpendicular diagonals. So that's another way you can do it, is find the slopes of the sides and find the slopes of the diagonals. Okay, for the next problems, we are going to actually apply our learning. So this one tells us that it is a rhombus. So it tells us that AB is equal to 26. It tells us that DE is equal to 8. It tells us that AC, this whole side, I'm going to use a different color pen. Sorry, not side. This whole diagonal is equal to 26. Okay, so now we have to fill in the missing parts. What I like to do is, before I even start looking for those other letters, is just fill in what I know, right? If it's a rhombus, that means that all the sides are the same. So I could put 26 here, I could put 26 here, I could put 26 there. And then remember that diagonals bisect each other. So that means that this little piece, if this little piece is 8, this little piece is 8. If this whole entire length is 26, and I know it gets chopped in half evenly, I could say this part over here is 13 and this part over here is 13. So I've filled in all the information. Now I'm going to look for stuff over here that I'm trying to find. Okay. So from A to E, AE, so from here to here, I know, I already wrote the answer, 13. Bam. From B to D, so from, let me use a different color. We'll go orange this time. So from B to D, all the way across, I have part of that is 8. The other part is 8. So altogether, that is 16. And then from B to C, I'll go purple. So B to C, my big old fat hand in the way, sorry. B to C, I know is 26. Okay, so pretty easy, right? Question number 2, now it's giving us some information. It's saying from Q to S, so that diagonal, so QS is this one right here, QS. And then from R to T is here to here. So both of those are diagonals, and it tells us that it's a rectangle. Okay, so look back up here. Remember about rectangles? We know that the diagonals are congruent, which means that they're equal to each other. Okay, so I can say, if I know it's a rectangle, I can say 5x minus 31 has to be equal to 2x plus 11. Okay, so now I'm just going to solve that equation. Remember, I like to get rid of the smaller x first, whatever side it's on. So then I have 3 x's left when I take away 2 from both sides. Over here, I took away all of them, so there's none left. And then I just need to add the 31 to the other side. So I get 3x is equal to 42. And then I'm going to divide by 3. And then remember, I like to do short division. So 3 goes into 4 one time with 1 left over. And now it's 3 goes into 12. So 3 goes into 12 4 times. So even if you didn't know that math fact all the way up to your 14s, we can do short division and get the answer pretty quickly without a calculator. Okay, so question number 3, it says decide whether the parallelogram is a rhombus, a rectangle, or a square. So they're already telling us that it's a parallelogram. So we already know that the opposite sides are going to be parallel. So let's go ahead and plot the points here. So A is, and just to review, remember that we go left or right. So this is minus, this is plus, or we go up and down. So plus and minus, depending on which one we're looking at. Remember, this is the x direction and the y direction. So for point A, we're going to go over to the right, since it's positive, to the right by 1 and up by 4. 1, 2, 3, 4. I'm going to put an A right there. B is over by 3. 1, 2, 3 to the right and up by 1. So this is B. C is over by 5. So 1, 2, 3, 4, 5. And up by 4. 1, 2, 3, 4. So that's C. And then D is over by 3, up by 7. So we've got 1, 2, 3, 4, 5, 6, 7. Okay. So now I'm going to connect the dots. Okay, and we're going to find the slope on each of those from A to B. A to B, B to C, C to D, and then D to A. Okay, so from A to B, we went down by 3, over by 2. So A to B, down by 3, over by 2. From B to C, we went up by 3, over by 2. From C to D, actually, we usually move left to right. So I'm going to go from D to C. We went down by 3, over by 2. And then from D to A, or A to D, we like to go left to right. I went up by 3, over by 2. So up by 3, over by 2. Sorry if you can't read my writing there. Kind of hard with the fat pen. Okay, so first of all, we want to say, are those perpendicular? Well, remember, for perpendicular, we had to have opposite reciprocals, where we flip the fraction and we do opposite signs. Okay, well, let's look at this one. Okay, we have opposite signs, but did I flip the fraction? I did not. Okay, so if they've already told us it's a parallelogram and we have same slopes here, and they're just asking us to differentiate between rhombus, rectangle, or square, I know it can't be a rectangle or a square because they're not perpendicular. So this one is a rhombus. Technically, what we would want to do is also show, to prove that it's a rhombus, we would want to show that the diagonals are perpendicular. Okay, so you could show that. You could say A to C has a slope of 0, and B to D has a slope of undefined. So we know that the diagonals are perpendicular. So that's another way that we know it's a rhombus, when the diagonals are perpendicular, but the sides are not. Okay. All right, question number 4 here. We're going to plot the points again. I'm going to switch colors. I'm bored of pink. Okay, so let's go purple this time. All right, so A is over 1 to the right, up by 1, 2, 3, 4. So that's point A. B is over by 4, up by 9. So 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 6, 7, 8, 9. So that's point B. C is over 9, up 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3, 4, 5, 6. I'm not messing this up here. And then D is over 6, up 1. So to the right by 6. 1, 2, 3, 4, 5, 6, up by 1. Okay. So we're going to, I forgot to put a D down there. Connect all the dots there. Okay. So now we want to find the slopes again. So we're going to go from A to B, B to C, C to D, and D to A. You guys noticing a pattern yet? Every time there's a graph, we list out all the slopes. You guys are going to have to do that on the quiz on Friday. Okay, so now I'm going to count it out here. From A to B, I went up by 1, 2, 3, 4, 5. So up by 5 and over by 3. So up, positive 5 over 3. From B to C, I went down by 3 and over by 5. Okay, then from C to D, I went, we're we technically should go from D to C, so we can move left to right. We went up by 5 over by 3. 1, 2, 3, 4, 5, yeah. Up by 5 over by 3. And then from A to D, we went down by 3 and over by 5. Okay, so we know it's not a rhombus because these are opposite reciprocals, right? I flipped the 3 and the 5 and I have opposite signs. One's positive, one's negative. So I know it's not a rhombus. So I know it's either a square or a rectangle. Okay, if I were doing a little bit of Pythagorean theorem here, I could find the lengths of those. The other thing I can do is find the diagonals, find the slopes, and see if those are perpendicular or not. If the diagonals are perpendicular, then we know it's a square. If the diagonals are not perpendicular, then I know it is a rectangle. I'm going to go from here to here and here to here. Okay, so from A to C, I went up by 2 and over by 1, 2, 3, 4, 5, 6, 7, 8. So up by 2, over by 8. So if I reduce that, I get 1/4. From B to D, I went down by 1, 2, 3, 4, 5, 6, 7, 8. So down by 8 and then over 2. So -4 over 1. So because the sides and the diagonals are perpendicular, I know it is a square. Sorry, I'll move my fat hand here. Okay, square, just holding down my page. All right, so now we're gonna go ahead and go over the odd answers to the homework for tonight. So I'm gonna move over to that. All right, so homework for 7.3. It says the diagonals of rhombus ABCD intersect at point E. Given that measure of EAD is 67, CE is 5, and DE is 12, we need to find some information. Okay, so first of all, if it's a rhombus, I know that all of the sides on the outside are equal. I also know that these diagonals bisect each other. So for AE right here, if this little piece is 5, then I know A to E is also 5. Okay, and then if I know that E to D is 12, the piece I'm looking for is B to E. So I know that one is also 12, because remember, the diagonals bisect each other. So I know that one is 12. Okay, oops, I wasn't supposed to do the even one. Sorry, just pretend like I didn't do that. All right, question number 3. Find the lengths of the diagonals. Okay, so this one's a little bit tricky in the way that the question is worded, because first we have to solve for x, but then we have to plug it back in again, okay? So J to L is one of the diagonals, K to M is the other. Because it is a rectangle, I know that they're congruent to each other, which means I can make these equal. So 3x plus 4 equals 4x minus 1. Remember, I like to get rid of the smaller x. So I'm going to go minus 3x on both sides. So I'm going to pull away from both sides what they have in common. They both have at least 3 x's. So this side is left with 4. This side is left with 1x. And then I can add that 1 to the other side. So x equals 5. Okay, so now the tricky part is it says find the lengths. It doesn't say find x. So now we know what x is, we can plug that back in. So I'm just gonna plug into the top one, it doesn't matter, they should both give you the same exact value. So I'm gonna go 3 times 5 plus 4. I just got that from right here, and I took the x value and I plugged it in for x. Okay, so 15 plus 4 is equal to 19. And I know they're both the same, right? If I plugged it in, 4 times 5 is 20, take away 1, still got 19, okay? Number 4, look in your notes. Question number 5 says find the lengths of the diagonals of the rectangle for this one. Same type of problem as number 3. So I'm going to let you guys do this one on your own. You would start it exactly the same way. I'll help you with the first step just because we have that decimal there. So we have 2x minus 6 equals 1.5x plus 1. When you subtract the smaller one, minus 1.5x, it leaves us with 0.5 of an x, okay? So we get equals 1 over here. Okay, I'll help you a little bit farther than that. Okay, so 0.5x equals 7. If I divide by 0.5, it's like the same thing as multiplying by 2. How many halves can go into 7? Well, 2 halves in each whole. If we do that 7 times, we get 14 of them. So if you didn't have a calculator, that's how you should think about that. Now, I'm not finishing it because that's not the right answer. You still have to plug it in, okay? Plug it in to get your final answer. That is not the answer. If you put that in Canvas, it'll be wrong. Okay, so take your value, times it by 2, minus the 6. That'll be your answer. So finish that problem the rest of the way. Okay, we're going to skip question 6 because we're just doing the odds here. So question number 7, we're going to plot the points. So we know that A is negative 5, 1. So 1, 2, 3, 4, 5, 1. B, so that's A. B is negative 3, 3. So 1, 2, 3, and 1, 2, 3. C is 3, negative 7. Okay, so 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. My eyes are almost like 40 years old, so this is a little bit challenging. They're really good vision, but these little boxes are kind of small, huh? Okay, and then D is over 5 and then down by 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, so right away, you guys, if the choices are rectangle, rhombus, or square, just looking at these values, I have a pretty good guess if those are the options. But we should still show our work and try to. Okay. So remember that our steps are finding the slopes from A to B, B to, oh wait, just kidding, B to D, D to C, and then C to A. Okay, and it doesn't matter what order you put the letters, just make sure that each side is represented there. So from A to B, I went up by 2, over by 2. And then from B to D, I went down by 1, 2, 3, 4, 5, 6, 7, 8, 8. So I went down by 8. And I went over by 1, 2, 3, 4, 5, 6, 7, 8. Okay, D to C is actually C to D. So it's going to be up 2 over 2. And then A to C is also going to be down by 8 over by 8 if you count it out. Okay, so this isn't the way we want to leave it though. We want to leave it reduced. So this is going to be positive 1, negative 1, positive 1, negative 1. Think about if I flip over 1, I still get 1/1. So these are opposite reciprocals. So I know it's either a square or a rectangle. It's not a rhombus because those are perpendicular to each other. Positive 1 and negative 1 are opposite reciprocals. And then I would just need to find the slopes of the diagonals from B to C and A to D. Those clearly are not going to be perpendicular. So I know that this is a rectangle. Okay, and I can see this little side is not going to be equal to that side. If you wanted to fully show your work, you would show the slope from A to D and the slope from B to C and show that they are not opposite reciprocals of each other. And they can't be because they're both negative slopes. So we know that they're not perpendicular. Diagonals are not perpendicular. So I know it's not a square. It's not a rhombus, so it's a rectangle. All right, last question. Man, these take forever, huh? Are you guys so bored? Okay, we're almost there, you guys. Thanks for persevering. Okay, so A is going to be -1, -5. 1, 2, 3, 4, 5. B is -3, -3. So -3, -3. C is to the right by 7 and up by 3. 1, 2, 3, 4, 5, 6, 7. Up by 3. And then D is 5, 5. Hold on, I should have labeled these. A, B, C, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That does not look right. What did I do, you guys? Oh, I know what I did. -1, -5. Okay, 1, 2, 3, 4, 5. Again, trying to talk and write at the same time. Okay, but that might happen to you guys too, right? You plot something, you're like, this does not look right. So that doesn't mean just keep going. That means stop, look back, check your work. I did that on purpose just so that you guys can see the right thing to do. Just kidding, I messed up, but it's cool. We all make mistakes. Okay. I should have been using pencil though. All right, so there we go. This one is looking like another rectangle, you guys. Not gonna lie. Okay, I'll put the work up here. We know it's a rectangle, but again, you wanna make sure that you're finding the slopes of the lines of the sides, showing that they are indeed perpendicular. This one, in fact, so from A to B, B to D, D to C, and C to A. I know from A to B, it's actually B to A. We went down by 2 and over 2, which is -1. From B to D, we went up by 1, 2, 3, 4, 5, 6, 7, 8, and over by 8, right? No, wait, 1, 2, 3, 5, 6, 7, 8. Yep. So 8 and 8, which is 1. This one we went down by 2, over by 2, which is -1. And 8 over 8, which is +1. Sorry, this is taking forever, you guys. Okay, and then to show your work correctly, we know it's going to be a rectangle. Okay, we've shown that the sides are perpendicular, so we know that all of those are right angles. But in order to distinguish between a rectangle and a square, even though we can see the sides are obviously different, if you were proving it, you would show that the diagonals are not perpendicular to each other. And so from B to C and A to D, we know that both of those are going up. So they're both positive. So they can't be perpendicular. Okay, so diagonals are not perpendicular, right? Because they're both positive. In order for them to be perpendicular, one has to be positive, one has to be negative, and they have to be reciprocals of each other. Okay, so that's it for 7.3, and I will see you next week. Bye.